So I'm going to do another practice problem for one mean hypothesis t-test, and this time I'm going to have sample data. Again, this is very different from the z-test because t-tests do not use a population standard deviation. So again, if you're not clear on z-test, I'd go back and watch those videos because once you have the understanding of that, t-test is a lot easier. So a researcher wants to know if statistic students watch more than an average of 2.5 hours per week. Using the sample data to determine statistics students watch more than an average 2.5 per week, the data is normally distributed using a 95% confidence interval, or level. So what I'm doing here is a researcher wants to know if a student watches more than 2.5 hours per week of television. This data might look familiar to what we used in the interval practice problems. And this happens a lot. Sometimes you find an interval and then you want to run a hypothesis test on it. So the responses are below. The first question is, the problem is a one mean t-test because there is no population standard deviation. That's it. That's the biggest deal about that one, is that there is no population standard deviation. Well, then when I go down to D, it says, what is the population standard deviation? Don't put 0, put none. None is given. NA, something like that. Never put 0 because 0, remember in statistics, 0 is a number and we can hold that as a value. So then it asks for my population mean, and my population mean is given in the problem. It is 2.5 hours. I don't have my sample mean, but I have a sample itself so that I can find it. Same with sample standard deviation. Level of significance. Well, I don't have a level of significance. I have a level of confidence, but 1 minus 0.95 equals 0.05. So that's my level of significance if I needed it. If it had asked for my level of confidence, and let's see, it doesn't, but that would have been my level of confidence. Remember, there's that inverse relationship between level of significance and level of confidence. Sample size, if I count them up, I get 15. So then it wants to know my correct null and correct alternative hypothesis. Here, it wants to know more than. More than does not have an equal sign. So that means I'm going to do it down here in this for the alternative. I'm going to start with my alternative because I don't have an equal sign. So I'm going to go to my symbols and I'm going to put my mean is greater than 2.5 hours. So the null is the mean is less than or equal to 2.5 hours. All right, so let's talk about that again. This was my original claim. So that's the one I'm going to start with. There was no equal sign because it was greater than. So go think back to when you were learning greater than and less than. Greater than just means a number is greater than another one. Greater than does not say that there's any equality between the two numbers you're comparing. So again, because there's no equal sign and it's a greater than sign, it's in my alternative hypothesis. This was all presented in z-test when we talked about hypothesis testing, and there's a table that might help you out to look at it. So how I got that null is, since I did my alternative first, the null is the mathematical opposite of greater than. So it's less than or equal to. Because when you're comparing two numbers, remember, they can be less than each other, equal to each other, or greater than each other. Okay. So those are my hypotheses. And then it asks for my t-test, my p-value, and my conclusion. Well, I can't get anything else of that because, again, I was given a sample of data. So what I'm going to do is this. I'm going to go to Minitab. I've already put my data in here for hours watched. So then I'm going to go Stat. I'm going to go to Basic Statistics, and I'm going to do one sample T. So I already have in here one or more sample, each in one column, and I have hours watched in there. Now I am going to click Perform a Hypothesis Test into 2.5. Well, where did I get that 2.5? again, it's my population mean, and it's right here in my hypotheses. I'm just using it again. I'm saying, hey, this is the population mean. Be mindful of it. Then I go to options, 95% level of confidence. And then for this one, this is my alternative hypothesis. And remember, I chose greater than. And if I go back to my document, you see here, my alternative has greater than. Manytab will always use the alternative hypothesis to run these tests. So then I hit OK, and I'm given something. So I'm going to click on this. Let's do this. I'm going to click on this. If it'll let me, yeah, it will. And I'm going to copy it, and I'm going to put it in my document so I can look at it. All right, so here I have my information. And let me go back and get the rest of it because it gave me more information that I need. So I'm going to copy this. And I'm going to put it, let's see if I can put it up here. Okay. So again, I have everything that was given to me in Manytab. So now it asks for the sample mean. Well, the sample mean is given right here. It's that 4.400. So that's my answer for sample mean. Okay. And then my population standard deviation is not given. And then it wants to know sample standard deviation. So this is 2.586. Where did I get that? It's right here. Okay. Sample size of 15, and then it gives me all that stuff. All right, what is my t-test statistic? My t-test statistic is right here. And let's talk about something right fast. This is really wonderful what Manytab gives me. It gives me my null, and we have to be careful because for Manytab, the null hypothesis is always equal. In the course that we teach you at Georgia Highlands, we do it a little bit different. And there's reasons we do it different, and there's two trains of thought. Some people want the null always to be the equal, and other statisticians want it to be every mathematical thing that can happen to kind of explain any situation. For us, we feel that it's better that you understand the less than and equal to for the null and not just the equal. So the alternative is the one you really need to look at. The alternative, the mean is greater than 2.5. So that gives me a t-value of 2.85, which I'm going to put here, 2.85, and then a p-value. Let me look at that p-value of point, and it's right here, 0.006. So I'm going to go here and put 0.006. All right. So I need to compare my p-value, 0.006, to my level of significance. And again, I have it right here. I figured it out for F. Okay, but this can also be confusing. So look, I have 3 decimal places here, and I only have 2 here. If it confuses you, just add a 0 to give it equal decimal places. So now it's almost easier to compare because I have 6 versus 50. So I do know that 6 is less than 50. So because of that, so if P is less than or equal to the level of significance, you reject your null. Okay, so what does that mean? That means I'm going to go here to the null, and I hate that it's on 2 different screens. Let me do this. Let's make our lives easier. So this is false. I'm going to say false. I would prefer to say not true, but we're just going to say false for right now. This is false, and this one is true. Okay. Well, that makes it easier when I have to do my original claim conclusion. Because remember, my original claim was that the mean hours was greater than 2.5, and that's a true statement. So I'm going to go back up and see what was it asking for. It wants to know, a researcher wants to know if they watch more than an average of 2.5 per week. So what I'm going to do here is I'm going to go here. I'm going to copy and paste my original claim, and I'm going to change it a little bit. I'm going to say statistics students do watch more than an average of 2.5 hours per week. Okay. And I'm even going to add some more stuff to it. I'm going to say this: at the 95% level of confidence. Okay, why did I do that? Because it was in the original statement. For me, when I write these, when I'm doing literature, I start with either my level of confidence or my level of significance that was given to me in the original problem. Then I do the conclusion. And if you look, statistics students do watch more than an average of 2.5 hours per week. This is the exact same in English words as what this is in the alternative, comma. And then if you wanted to, I sometimes do this. T equals 2.85, comma, with a p-value of 0.06. That's how I'm doing it if I'm writing it in for research. And there's some other things I can do to it, but I have shown that the statistics students do watch more than an average of 2.5 hours per week. And that was supported by the p-value and the level of confidence.